Good morning to all. In the previous session, we have discussed what are interrupts, types of interrupts, interrupt vector table, and interrupt service routines. In this session, we will be discussing about what is an interrupt cycle of 8086. So just an overview of what we have discussed or what are the types of interrupts we have. Basically, interrupt are of two types. We can call this one as external interrupt and internal interrupts. External interrupt nothing but hardware interrupt. Internal interrupt is nothing but software interrupt. External interrupt, we can give an example of a keyboard interrupt from outside, which is generated outside the processor. Internal interrupt are being generated by the instruction in the program, interrupt instruction in the program. For example, we can go for divide by 0, like int instructions, overflow interrupts. Suppose an external device interrupts the CPU on interrupt request pin, either interrupt request pin or we can go for NMI, non-maskable interrupt, while the CPU is executing an instruction of a program. So what it does, the CPU first, so what is an interrupt cycle? What it does, the CPU first completes the execution of the current instruction, first step. Second, the IP is then incremented by or I can call IP is then incremented by pointer to the next instruction. The CPU then acknowledges the requesting device on its int acknowledge bar pin immediately. If it is a NMI, trap or divide by 0 interrupt, if it is int request, the CPU checks the IF flag. If the IF flag is set, the interrupt request is acknowledged using int a bar pin. If the IF is not set, the interrupt requests are ignored. So this is what interrupt cycle follows. For suppose an external interrupt has been occurred on the interrupt pin with the help of either interrupt request or NMI, while the CPU is executing some program, some instruction. So what the CPU will do, first step is complete the execution of the current instruction, stops. The IP instruction pointer is then incremented to point to the next instruction where an interrupt has been occurred. The CPU then acknowledges the requesting device on its int acknowledge bar pin immediately if it is a NMI or trap or divide by 0 interrupt. Right? If it is an interrupt request, the CPU checks the IF flag. If the flag is set, then it acknowledges to the int a bar pin that interrupt has occurred. If the IF flag is not set, then it is interrupt requests are being ignored. The responses to the NMI, trap or divide by 0 interrupt request are independent of the IF flag. They are not dependent on the IF flag. So if an NMI interrupt occurs or trap interrupt occurs or divide by 0 interrupt occurs, IF flag not changes. They are not independent. So after an interrupt is acknowledged, the CPU computes the vector address. What is the vector address? In the interrupt to vector table, which type of interrupt, depending upon the type of interrupt occurs, it computes the vector address from the type of the interrupt and processor executes the ISR of the corresponding interrupt. So what is the ISR? Depending upon what program, what ISR has written, that program will be executed. If further interrupts are to be responded, so there are more number of interrupts during the program, then the time of the first interrupt is being serviced, the IF should be set by the ISR of the first interrupt. If the interrupt IF is not set, the subsequent interrupt signals will not be acknowledged by the processor till the current one is completed. Getting a point? If the interrupt flag of first interrupt is not set, then the subsequent interrupt signals will not be acknowledged by the processor till the current one is completed. The programmable interrupt controller is used for managing such multiple interrupts based on their priorities. At the end of ISR, the last instruction should be IRET. Interrupt return. When the CPU executed IRET, the contents of flag, IP and CS were saved before the execution of ISR are now retrieved to the respective registers. The execution continues onwards from this address received by IP and CS. Nothing but back to the current program execution. See, getting a point. So interrupt cycle, how it works, it stops the current execution, it completes the current execution of an instruction, it goes to the interrupt service routine, executes it, with the help of IRET instruction, it commences against back. So whatever the values are being stored previously after the execution, before the execution of interrupt service routine, the registers, whatever they have data, they will be again retrieved and it will process accordingly. See here, this is how your memory bank is. So this is my types of interrupts: ISR IP, ISR CS, main IP, so this is main IP. So an interrupt has been occurred. So what it here stops, the ISR it goes, ISR CS and ISR IP are being loaded onto the top of the stack and it executes that table. So after executing, again the main IP, main CS and then program status word will be fetched and the normal process executes. So as we all know, the type 0, we have type 255 which is FFH. So first one is the 0 divided by 0, single step, type 2, type 3, type 4, type 5, then next are coming for your intertypes. So normal processing, interrupt occurs, finish the current instruction, push the flags CS and IP onto the stack, branch to ISR, execute the ISR, pop flags CS and IP from the stack and normal processing resumes. This is how the interrupt cycle of 8086 follows. Yeah, so we'll discuss about NMI interrupt. So what is this NMI interrupt? Non-maskable interrupt, which is an external interrupt. So the highest priority will be given for NMI. Track single step 1, is an internal interrupt having the lowest priority. NMI is activated on a positive transition, low to high. The exertion of the NMI interrupt is equivalent to an execution of instruction into 02 type 2 interrupt. However, if an internal interrupt is being serviced and an NMI occurs, the ISR for the internal interrupt will be suspended and external interrupt is honored, even though it is of low priority. Priority structure applies onto simultaneous interrupt requests. So this is how the highest will be NMI, interrupt request, single step. So like this, the interrupt, if we have number of interrupts being occurred, suppose for example we have occurred some type 2 which is into 02, so it will execute that instruction before completion of execution of the corresponding interrupt service routine, an NMI interrupt has been occurred, then what happens? It stops the type 2 interrupt service routine, comes back to for a hardware or external interrupt caused by NMI, and it executes the NMI interrupt service routine. After completion, again comes back to the type 2, returns back, and again goes for the normal execution process. So NMI is a non-maskable interrupt, which means that it cannot be blocked. Int request, on the other hand, is maskable, that is IF. Only when this flag is set, interrupt on this input will be accepted. Although internal interrupts have priority over external interrupts, the NMI request will be honored as soon as the interrupt's ISR begins. The same is not true for the int request. Because the NMI pin is non-maskable, care must be taken when using this interrupt. Whereas int request is a maskable, can be changed, can be blocked, so no need of extra care. But while going for non-maskable, care should be taken. This is because there may be some programs that you do not want interrupted, reading or writing data to a disk drive, for example. So for this reason, NMI input is normally reserved for catastrophic events such as memory error or an impending power failure. So example we will take here, a particular interrupt has a type number n is equal to 41H. If the ISR begins at address 09830010H, determine the locations in the interrupt table to store this address. So what is the solution? The vector address is calculated by multiplying 4s. So n into 4 is 41, and by 4 is 0, 1. This is the multiplication. Rotate left twice, so we will get as 104H. IP is stored in the low word location and CS in the high word location. So 00107H is 09, 06 E3, 105 00, and 10 is, this is IP and this is CS. So stored as low 4, then high 00, then again low next, and high in the next address. So this is how the interrupt service routine addresses will be, or you can calculate the actual vector address. So the DOS functions and the interrupts, we have many interrupts like int 00H, int 21H, int 01H, int 02H, 09H. So int 21H, nothing but they are for DOS services coming to the DOS command prompt. Int 10H for video services. Int 21H is used for multiple purposes: to input a character, to input a string, to display a character, to display a string, and to terminate the program. So int 21H interrupt is being used for displaying certain data into the DOS prompt, command prompt, and terminate the program. Int 00H terminates the current program. So basically we will not use 00H, we will be using is 4CH, int 4CH. 01H, read a character from the bit with the echo. Int 02H, display single character. Int 09H, string the display. Total string will be displayed until the dollar is being reached. So dollar will be the last character which we require to display. So DX should have the address of the string to be displayed. Simple examples. So these are some of the screenshots which we used for our DOS box. So you can write a program and you can execute here. You will get the output. You have used here 09H, 4CH, 21H in order to display microprocessor. Just display the word which is microprocessor. We are using interrupt 21H. Next programming is interrupt occur. So two strings will be displayed as enter character and microprocessor. This is how you will be executing in the program step by step, and you can able to check the registers as well as the flags. So if I is 1, nothing but interrupt flag is set. A simple example to display a string. This is programming is fun. So to input characters until Q and display. This is how the output will be up to Q. So these are some of the programming. I have used here DOSBox. You can use as previously mentioned by AMU 8086 or MASM or TASM, whatever. Thank you.